Good day, everyone. Today is another wonderful opportunity to welcome you to Mathematics Solution Center. Today we are going to be looking at integration part 1. We are going to talk about the formula for integration of trigonometric functions, and integration of any form of algebraic functions. Okay, what is the symbol of integration? Anytime you see this symbol, you know that it is what? Symbol of integration. We can have A here and B here. Once we have that, then it means that what? It is a definite what? Integral. We have lower limit and the upper limit. What you will definitely do is by substituting your value of what? Upper limit minus the value of what? Lower limit in the expression you are going to get at the end of your integration. Okay. This is the symbol of integration. We have the formula for integration. Actually, integration is the opposite of differentiation. If I have a term, y is equal to ax raised to n. If we differentiate this term with respect to x, we are supposed to have what? An x raised to power n minus 1. If I should integrate a function like this, integration of ax raised to power n with respect to x, the answer I am going to get is what? X raised to power n plus 1. I will add 1 to the power of what? N, and then divide by the new power, n plus 1. That is what we are going to get. So in the same way, if I'm to integrate an x raised to power n minus 1 with respect to x, I am supposed to have what? My an x raised to power n minus 1 plus 1, that is n, divide by the new power, n. But anytime you integrate, always add what? A constant c plus c. Okay, you can see that n will cancel n, and we have our ax raised to power n back, as in this case. So differentiation of ax raised to power n is an x raised to power n minus 1. If I should integrate it, I'm supposed to have what? Ax raised to power n back. So integration and differentiation, they are just like word and opposite. Okay, but we have to know some constant terms that when you integrate them, what you are supposed to get. If I should integrate cos x, integrate cos x with respect to x, the answer I'm going to get is sin x plus what? C. If I should integrate sin x with respect to x, I'm going to get minus cos x plus c. Integration of sec square x with respect to x is going to be what? Tan x. Because if you differentiate tan x, it will give you sec square x. Therefore, integration of sec square x is what? Tan x. Let's also look at another one. Integration of cosec square x with respect to x. This will give you what? Minus cot x. Minus cot x plus c. So we will not be able to take all these values. You can just Google them and get more of them. Integration of an exponential function with respect to x, you are going to get the same result, which is what? Exponential function plus what? C. Okay, the last one I'm going to talk about constant and integrals, like 1 over x with respect to x. What you are going to get is what? Natural logarithm of what? X, then plus c. But don't forget that the initial formula given, as in x raised to power n plus 1 over n plus 1, will not work for when the power of x is minus 1. Is that taken? Will not work for that, because actually differentiation of lim x will give you 1 over x. So that's why we are taking the opposite of integrating 1 over x will be what? Lim x. Take note of that. Okay, let's start taking examples now. Integration of square root of x with respect to x. I know some students, once they see this kind of a square root of a thing or fraction something, they become so scared. Please, you just have to familiarize yourself with an expression like this. You don't have option. Okay, get used to it. Learn how to go along with it. Then, with time, you perfect yourself. This is the same thing as integration of x raised to power half, because square root is the same thing as raised to power half with respect to x. And then the rule still remains that what? increase the power by 1. Therefore, my answer will be what? 1 over 2 plus 1 over 1 over 2 plus 1, then plus C. So actually, this your 1 over 2 plus 1 is what? 3 over 2 divided by 3 over 2, then plus C. Okay, what are we going to have at the end of the day? It becomes what? 2 over 3 x raised to the power what? 3 over 2. But don't forget that what? If you are dealing with objective, it is possible that your answer may not be expressed in this format. So in what way can this expression be expressed? So I can have 2 over 3 into bracket square root of x raised to power 3 plus C. And it can also be what? 2 over 3 into bracket square root of x everything raised to power 3. It's still the same thing. Please study your laws of indices. You will understand this better. Okay, let's take another example. Let's take another example from here. What if I have an integration of 2x squared plus 3x plus 8 with respect to x? All you have to do, integrate each term individually. Then I'm going to have what? 2x raised to power what? 2 plus 1, increase the power, and divide by the new power, 2 plus 1, then plus what? 3x, increase the power, that is 1 plus 1, over what? The new power. Then plus what? There's 8 there at the back of 8. Once you have that, we have 8x raised to power 0. That is when we have just 8. There's x there. So increase the power by 1 over what? 0 plus 1. Then plus your C. Therefore, our final answer is going to be what? 2 over 3 x raised to power 3 plus what? 3 over 2 x raised to power 2. Then plus 8x. Then plus C. Integration of x raised to power 3 minus 3x squared plus 2x plus 5, everything divided by x, then with respect to x. We are integrating with respect to x. All you have to do, divide through by x. All the expression, everything you have there, divide through by x. So I have x squared minus 3x plus 2, then plus 5 over x with respect to x. Then integrate each term. I'm going to have what? X raised to power 3 over 3 minus 3x squared over 2 plus 2x, then plus, you have to be careful with this. This is the same thing as what? We have 1 over x there. This is the same thing as 5 into bracket 1 over x. But don't forget, integration of 1 over x is what? Is lim x. So I'm going to have 5 ln x, then plus C. So we've gotten our answer. Integration of this 2x plus 3 raised to power 5 with respect to x. At this particular stage, once you have something like this, you need to be careful. Under normal, you cannot go through the stress of what? Saying you want to expand this. If you expand it, yes, you will get an answer. You understand? We can use binomial theorem to expand this, but I will advise you it's a waste of time. Don't go through that method. Okay, see what you are going to do now. Anytime you have this, make use of your u. U is equal to what? 2x plus 3. Equate u to be equal to what we have inside the bracket. Differentiate u with respect to x. The u by the x is equal to 2. And then substitute in the expression. Don't forget that your ds is equal to what? Du over 2. Therefore, I have integration of 2x plus 3 is u, right? So I have u raised to power 5 with respect to x, but I will change my respect to x to what? Du over 2, because you cannot integrate u to respect to x. You can only integrate expression in terms of x with respect to x, and integrate expression in terms of u with respect to u. That's why you have to substitute for u here. So I'm going to have what? This is 1 over 2 is a constant. You can just take it outside. Don't disturb yourself with it. U raised to power 5 du. Okay, I'm going to have what? 1 over 2 times u raised to power 6 divided by the new power 6, then plus c. Then I'm going to have what? U raised to power 6 over 12 plus c. What is now my u? My u is actually 2x plus 3. So I have 2x plus 3 over 12. But 2x is raised to power 6, then plus c. That is our answer. Integration by substitution, take note of that. Now, whenever you have a fraction like this, take a look at the denominator. If I should differentiate the denominator, can I get something equivalent to the numerator? Yes, because if I differentiate x squared, I'm going to get 2x. Therefore, you take your u to be equal to what? U is equal to x squared plus 1. Therefore, the u by the x will be equal to what? 2x. Now make the x the subject of the formula. I have the x is equal to du over 2x. Therefore, I'm going to substitute in this expression. What am I integrating? 2x over what? U. So I have 2x over my u. Then the x is what? Du over 2x. Don't forget my u is actually 2x squared plus 1. That is my u. Okay, therefore 2x will cancel 2x. And then I'm going to have what? Integration of 1 over u, 1 over u du. Therefore, I'm going to have what? Integration of 1 over u, that is lim u, natural logarithm of u, plus c. That is what I'm going to get. Now, let's put the value of our u back. So I'm going to have lim x squared plus 1, then plus c. This is our answer. Okay, let's take a look at another example. If I should have integration of an x squared into bracket 3x squared plus 4x with respect to x. Am I going to use substitution? If I should use substitution, nothing is going to be cancelled. That is what you should look out for. This will not be cancelled if I differentiate this. So I don't need to use substitution here. All I'm going to do, I will just expand the bracket. Therefore, I have what? 3x raised to power 4 plus what? 4x raised to power what? 3. Then with respect to x, then I will integrate each term. I'm going to have what? X raised to power 5. Don't forget your 3 over what? The new power 5. Then plus what? 4x raised to power 4. Increase the power of x by 1 and divide by the new power. Plus c. We talk about this constant later. Then 4 we cancel 4. I'm left with what? 3x raised to power 5 over 5. Then plus what? X raised to power 4. Then plus c. This is the answer. Okay, let's take a look at another example. There are some simple examples that you think they are simple, but if you don't know how to go about it, you will still miss them. Integration of 3 over x raised to power 5. With respect to x, I am going to have, this is the same thing as 3 outside, then 1 over x raised to power 5. With respect to x, 1 over x raised to power 5 is actually the same thing as what? X raised to power minus 5 with respect to x. Then you can now apply your law of integration. 3 into bracket, increase the power of x. I have minus 5 plus 1, that is minus 4, divided by the new power, minus 4. Then plus c. It is an answer already. It's just that you just have to, sometimes you need to rearrange your options. Then I have minus 3 over 4, x raised to power minus 4 is plus c rather. Plus c. Which can still be expressed as 3 over minus 3 over 4 x minus 3 over 4 x, because x raised to power 4 minus 3 over 4 x raised to power 4. Integration of 7 over 5x minus 4, everything raised to power 5 with respect to x. 7 outside, then integration of what? 1 over 5x minus 4, everything raised to power 5 here, then with respect to x. Then this is 7 integration of 5x raised to power minus 5 raised to power minus 5 with respect to x. Okay, but we cannot integrate the whole of this at the same time. You have to make use of your u. So u is equal to what? 5x minus 4. Please watch out for when you need to make use of u. Okay, because we have an expression raised to power minus 5. Even though it is raised to power 5, it is not possible for you to start expanding it. So you make use of your u. Therefore, my du over the x will be equal to what? 5. Therefore, let's make the x the subject of the formula. I have the s is equal to what? Du over 5. So we are going to substitute this value for the x. Therefore, I have 7 integration of what? U raised to power minus 5. Instead of the s, I'm going to have the u over 5 because you cannot integrate u with respect to what? X. So the 5 is also a constant. 1 over 5 is a constant. I will allow it to come outside. Over 5. Integration of what? U raised to power minus 5. Then du. I can now integrate this. So I have 7 over 5. Then into what? U raised to power minus 4 divided by what? Minus 4. Then plus c. Then I'm going to have 7 over minus 7 over 20. Then what is my u? 5x minus 4. 5x minus 4 raised to power what? Minus 4. Then plus c. Okay, I have minus 7 over 20 over 5x minus 4 raised to power 4 plus c. That can also be your answer. If we have integration of s squared exponential s raised to power 3 with respect to x. Okay, here you have to be very careful because we have what is called integration by parts. But I don't think I need to use integration by part here because I will just take my words. Let's take u to be equal to x raised to power 3 and let's differentiate. So I have the u by the x is equal to 3x squared. Make the s the subject of the formula. The s is equal to the u over 3x squared. Therefore, I'm going to have integration of s squared exponential u. My ds is what? The u over 3x squared. Therefore, the s squared will cancel the x squared. So I have 1 over 3 integration of exponential u with respect to u. So integration of exponential u is single term. U is a single term now. So it's the same thing as what? Exponential u, then plus c. Therefore, my final answer is 1 over 3 exponential s raised to power 3, then plus c. We have come to the end of this tutorial today. In case you have any question or comment, put it in the comment section. Thank you for watching. This is Mathematics Solution Center. Thanks.